Geometry, Unit 5, Section 2, Parallelograms. The previous video was on trapezoids, and a trapezoid was a quadrilateral with at least one pair of parallel sides. A parallelogram is a trapezoid because it has at least one pair. But it has more than that, it has two pairs of parallel sides. So it is a trapezoid because it still has at least one pair. But a parallelogram has exactly two pairs. Both pairs of opposite sides are parallel. So DC is parallel to AB, and AD is parallel to BC. So we have all that. Parallelogram properties, there's a bunch of them. So not just the arrows here, and I want to redraw this arrow because that's sloppy, that'll bother me. So not only do we have opposite sides parallel, and let's see, both pairs of opposite sides parallel, that was the second one here. Let's write down what that means. So why did I write AC? Let's say DC is parallel to AB, and AD is parallel to BC. So two sets of parallel sides. And wherever we see parallel, we always need to, look for alternate interior angles, corresponding angles. Doesn't always happen, but we do always want to look for that. So we got opposite sides parallel. Both pairs of opposite sides are not just parallel, but both pairs of opposite sides are also congruent. So we also could put congruent slashes through these. So congruencies. So opposite sides are not just parallel, but also congruent. So DC is, that's up here. DC is congruent to AB. And AD is congruent to BC. Okay, so opposite sides are both congruent and parallel. Both pairs of opposite angles are congruent. So not just opposite sides, but opposite angles. So angle A is congruent to angle C. This is different than what the trapezoid was. The isosceles trapezoid, where the base angles were congruent. This is not the case for parallelograms, rectangles, rhombus, things like that. We always say opposite angles are parallel. And the same goes for D and B. And I really shouldn't throw a rectangle in there because, well, all the angles are congruent in a rectangle. But we'll get to that in the next video. So opposite angles are congruent for a parallelogram. And so that's angle A is congruent to angle C, and angle D is congruent to angle B. And this is the kind of useful information that you're going to need to do a triangle proof. You could say the opposite sides are congruent if they happen to be the sides of the triangles you're proving, or opposite angles are congruent, or opposite sides are parallel, which might lead to alternate interior angles, all that type of stuff. Consecutive angles are supplementary, so that's the ones that are not opposite, like A and B are supplementary. They add to 180. B and C are supplementary. They add to 180. D and C, A and D. So consecutive angles, the ones next to each other, are supplementary relationships. We don't really see that much in proofs, but that could be an algebra type of question, like if you're told this is 2x minus 1 and this is 3x plus 5, well, we could add them together and set it equal to 180, that kind of thing. Diagonals bisect each other. So there's a diagonal property here. Remember, a diagonal is the line that connects opposite angles. And for a parallelogram, diagonals are not congruent. They can be, but the basic parallelogram, that's not necessarily true. What's definitely true about a parallelogram is the diagonals bisect each other. So that means that they cut each other in half. So this is congruent to this, and this is congruent to this. Again, that might be useful if I'm trying to say prove this triangle is congruent to this angle. I could say opposite sides are congruent, diagonals bisect each other. I could do vertical angles here. I could do alternate interior angles. There's a lot of different things we could do through that. But that's an important property, that the diagonals bisect each other. Not necessarily congruent. We can't say congruent. That would require a isosceles trapezoid or a rectangle or a square, but not if you're told it's just a parallelogram. The diagonals are not congruent. They don't look congruent right here, do they? Well, let's take a look at a proof. So we're given ABCD is a parallelogram here, and this needs to move down a little bit. There we go. ABCD is a parallelogram, and this is what's getting difficult about our proofs. Being told that that's a parallelogram, there are a lot of different properties that could be used here, and maybe it's just one property that I'm using, and that's it. Or maybe it's 3 properties I'm using. So you don't know how many congruencies you're going to get from being told ABCD is a parallelogram. It could be 1, it could be all 3. And that's what makes it a little challenging, so you kind of really need to think about all the properties we have. So I'm trying to prove, well, EC is congruent to AF, and the way I'm going to do that, those are not diagonals, by the way, because diagonals go from like A to C, not E to C. E is not one of my angles of the parallelogram. So I'm going to get CPCTC to do that for me, and that means I want to prove this triangle is congruent to this triangle. So first, let's say, are opposite sides congruent helpful? And yes, they are, because DC here and AB are opposite sides of a parallelogram, and they're both also sides of the triangles I'm trying to prove. So that's why my first given there is that. And so my reason is opposite sides of a parallelogram are congruent. Opposite sides of a parallelogram are congruent. That's why I can say that. Okay, how about the other opposite sides? Yeah, they're congruent, but that's not much. Like being told that this is congruent, I'd have to subtract EA, but I don't know that what I'm oh, actually I do see that there. Maybe I will be using that. So let me hold on to that, because I do see that EA and CF are congruent. So maybe I will be doing some subtraction, but so let's hold on to that. It's not the next thing I have listed. We'll go back to that. Opposite sides parallel, is that useful here? Well, for that to be useful, you're looking for alternate interior angles, and there's not really a transversal connecting both of my parallel lines. Like, I can't call this a transversal because it's touching this parallel line but not this parallel line. It is touching both of these, so like this angle is congruent to this angle. That I could do that alternate interior, but that's not really helpful with my triangles, so that's not going to be useful here. Diagonals bisect each other. The diagonals are not even drawn, so I don't need to worry about that. But how about opposite angles congruent? This angle congruent to this angle, it's not helpful for the triangles, but angle D and angle B, those are helpful for the triangles. Those are angles of my triangles. So that's my next statement here, and my reason is opposite angles of a parallelogram are congruent. All right, and then I kind of hinted at it before that AE and CF being given this congruent to this, how is that helpful? Well, we do know that AD is congruent to BC, and those are opposite sides of a parallelogram congruent, but they're too long. Like my triangle side is DE, not DA. So I'd have to cut off EA. I'd have to subtract EA. And over here, I don't want BC, I want BF, so I'd have to subtract CF. And the only way I could subtract different segments is if I knew those different segments were congruent, such as this. So because of this given, I am going to be doing some subtraction. And so this is because, again, opposite sides of a parallelogram are congruent. So the order could have been a little different here in this proof. I could have done this opposite sides, and then I could have done this in the same given, and then I could have done my subtraction, and then I could have went to the opposite angles congruent after that. So the order of this could be a little different. And then since these are the same length, and these opposite sides are the same length, I could subtract off these pieces. I could do AD minus the AE and BC minus CF to get the side congruence that I want from that, and this is simply subtraction. So there's your subtraction. Sometimes it involves reflexive, but not always. Same thing with addition. And so that was the side congruent. So we also had opposite sides congruent there and opposite angles congruent there. That gave me my three congruencies. And so I do end up with these sides here. And so I have a side, an angle, and a side. So there's my two triangles being proved together as side, angle, side. And I named them here for you, but remember, you got to make sure a corresponding order. So if I'm going to call it DEC, what corresponds to D is B, what corresponds to E is F, what corresponds to CA. So it's going to have to be BFA. DEC and BFA. So now that my triangles are congruent, I can say EC and FA are congruent through CPCTC, because they are corresponding parts of now congruent triangles, which makes them also congruent. So that's your parallelogram. You got to know all of these properties and be ready to use all of them at any given proof. And what we'll take a look at in the next video is the rectangle, which is a trapezoid. It is a parallelogram, but it's got some special properties of its own. All right, see ya.